I'm initiating the valve sequence. Check the flow rate.
Flow rate is stabilizing.
Good.
Check the pressure gauge on the third stage. It seems high.
Yeah, I see that. Let's cross-reference it with the flow rate on the tablet.
This animation reveals how the three-phase separator efficiently divides the incoming stream into distinct layers of gas, oil, and water.
The flow rate is stabilizing. Check the pressure reading on the tablet.
Confirmed. It's within parameters now. Flashing red on the schematics. Pressure levels are critical.
Adjusting the flow rate now. Monitor the stabilization on screen 3.
We're seeing low pressure on the main line.
Adjusting the choke valve.
Monitor the downstream pressure closely.
It's holding steady at 500 psi.
Bridge engine room reports green across the board. We are clear to continue loading at current rates.
Flashing red on the schematics. Pressure levels are critical.
Adjusting the flow rate now. Monitor the stabilization on screen 3.
We're seeing low pressure on the main line.
Adjusting the choke valve.
Monitor the downstream pressure closely.
It's holding steady at 500 psi.
Bridge engine room reports green across the board. We are clear to continue loading at current rates.
The pressure in sector gamma is fluctuating. Keep a close eye on the flow rate.
We should reach the waypoint by 1600 hours.
Maintain current speed, and the weather looks clear ahead. The manifold connection looks secure, but keep an eye on the hull stress during the transfer. We need to follow the revised plan exactly.
We should reach the waypoint by 1600 hours.
Maintain current speed, and the weather looks clear ahead. The manifold connection looks secure, but keep an eye on the hull stress during the transfer. We need to follow the revised plan exactly.
Check the pressure on this gauge. It seems a bit high.
I noticed that. Is the motor running hot?
Yes, we should log the vibration levels too.
Check the seam right there. Oh! Looks like corrosion.
Check the reading on the main injector valve. The gauge looks good, and the light is green.
Confirmed. Data stream shows stable operation across the board.
Check the gauge again. See that spike when I tapped it?
Yes, but the flow still looks steady toward the refinery.
The pressure reading is fluctuating slightly above the baseline.
I see that. The flow rate is steady, though. I'll log the variance.
Check the velocity on section 4. Heaven's higher.
It's higher than the projection. I'm logging it now.
Look at the reading on this gauge. It's unstable. I see it. I'm making a note now.
The pressure on the main valve is still reading high. Are we clear to proceed with the flush sequence?
Negative. Stand by.
This section routes directly to the main manifold. See here.
Yes, I've checked the schematics against the physical layout. It aligns.
Keep an eye on this flow rate here. It's slightly high.
Adjusting the valve now. It's normalized.
Perfect. Watch the pressure next.
Valve position is confirmed. It's fully retracted.
All right, I've logged the adjustment and the pressure reading.
The vibration seems high on the intake. It is within tolerance, but keep an eye on the bearing temperature.
The pressure on gauge 3 is stable, but we should verify the flow rate here.
Tablet confirms it's within tolerance. Let's sign off on this section.
The flow rate looks good, but check the pressure on gauge 3.
Got it. Looks stable to me.
The viscosity is holding steady right at the target.
Perfect. I'll make a note on the report.
Check the flow rate on auxiliary panel 3.
Reading steady at 500 liters per minute.
Acknowledged. The convoy is approaching the bottleneck. Inform the depot we anticipate a 20-minute delay on shipment 302.
Ground control, this is Unit 4. Refueling underway on Flight 75B. Pressure steady at 50 psi.